Hey guys, this is Wojtek from Jolly Monster Studio, and today we're going to continue with part 5 of our player character series, talking about playing sounds. Now in our last lesson, we talked about cutting and importing WAV files, and today we're going to take those WAV files and attach them to a SoundCue object, which is kind of like a container for our sound files. And then we're going to expose that SoundCue object through our blueprint for easy manipulation. We are then going to take that sound cue and attach it to an audio component, and the audio components allow us to control the playback, stopping, and slight adjustments of our sound once we have it within our C++ code. And then lastly, we're going to use that audio component to actually trigger the playback of the sounds and introduce a little bit of pitch modulation to create some variance in our sounds. So let's get started. Alright guys, so before we get started with implementing our playing of sounds, let's actually bring in our sound asset into Unreal. And to do that, just open up your project definition, or wherever you have, the sound effect you want to work with, and drag it over into our tutorial resources audio folder. So that brings in our sound, and once we have the sound in Unreal, we can now start creating a sound cue from it. So to do that, in the same folder, we're going to right-click, go to Sounds, and then find Sound Cue. And we're going to call this Sound Cue our Punch Sound Cue, for lack of imagination. And what this guy allows us to do, when we open it up, is basically attach multiple inputs into our output speaker. So we can configure sort of the flow of the sound as it comes from our WAV file through these various modifiers here into the output. But in our case, we're just going to work with a very simple sound effect. So you have a couple of different ways of bringing in that WAV file into this blueprint. You can minimize your little sound cue window and drag in the punch sound. Or, alternatively, you can right-click, find Wave Player, and then for the Wave Player node, you can select the specific sound you want to work with. So in our case, it's going to be Punch 01. And the similar paradigm works with a lot of the blueprints within the Unreal Engine. You can either drag in from your content pane, or there's accessors to get at those assets that you're bringing in. So in our case, we only need one of these guys. So I'm going to turf the first one. And then let's just make sure that it actually works. So to do that, you drag the output node from the wave player into the input node on the output speaker. And when we play it back, we have our punch. And you'll notice there's a pile of settings on the left-hand side for the sound cue: volume, pitch, sound classes, attenuation, all kinds of stuff. And then likewise, right-clicking presents us with various modifiers to our sound, Doppler, looping, mixer, modulation, oscillation, all kinds of stuff. But in our case, we're just going to go with this very simple setup. Now that we have our sound cue in place, we can right-click on it in order to find its reference, which we're going to need for our C++ code. So there's our reference, and now we can switch over to Visual Studio. So we're going to start off by introducing a new property into our player character header definition. And similar to our montage, I'm just going to do it right underneath here, we're going to create a new U property, and we're only going to allow editing of defaults because we want to be able to swap in that sound cue as we develop our effects. We don't necessarily want to be locked down to just going through the C++ code because it makes it a little bit longer from just a testing standpoint. You end up having to flip between your code, compilation, and Unreal. And in this case, we're just going to expose it as a variable, and then we can modify it as much as we want. So it's going to be a property where we edit the defaults. It's going to be blueprint read-only. The category is going to be audio, and we'll include the meta definition, which I'm just going to copy and paste. There we go. So our class is going to be a USoundCue, and we're going to call this our punch sound cue. Now, similar to the montage, we want to ensure that there's a default sound cue present if one from the blueprint is not provided. So to do that, we're going to pop up in our CPP file, go down to the player character constructor, and again, somewhere below the section where we have our melee attack definitions, we're going to now bring in our sound cue. So load the sound cue object, and we're going to use the exact same constructor helpers as well as the object finder definition, but we're going to type def this as a sound cue, and we're going to call this variable punch sound cue object. Now this takes in a textual reference to our location wherever the sound cue is defined. So I just lost my buffer. Let me grab it again. So right click on sound cue, copy reference, and let's go back to our code. And there's our sound cue definition. Again, you always want to make sure that these guys are loaded before we pass it to our variable. So we want to say punch sound cue, sound cue object succeeded, and then we pass it to our punch sound cue variable. Cue object, and then we grab the object reference from that definition. So there we go. Pretty straightforward. And now we're going to recompile and just double check that our blueprint is correctly reflecting this new parameter. Okay, everything's recompiled. Let's take a look at our player character. So go to third person CPP blueprints, and there's our third person character blueprint. So when we look now on our third person character's object definition, you'll notice we have our sound cue in place, and if we so choose, we can swap it out for some other sound effects. And this is going to make our development and our manipulation of the sounds much, much easier. Great, so we're pretty much halfway there. Now we need to figure out, well, how do we actually trigger the playing of the sound cue within our project? And to do that, we're going to rely on a UAudioComponent. And audio components allow us to basically pass in a sound definition and then control the playback, reversal, stop, all those sort of operations we want to perform on our sound. To add in our audio components, we're going to flip over to Visual Studio, and we're going to go to our header definition. And right underneath our box component, we're going to bring in a new component, which is called audio component. And then what we can do is instantiate this variable. So to do so, we're going to actually create a private variable, because we're not going to be exposing this audio component to the general public, rather just the sound that the component controls. So this is going to be a UAudioComponent, and we're just going to call it a punch audio component. And similar to our sound cue, we need to instantiate this variable and then actually attach the sound cue to the audio component. So to do that, we're going to flip over to our CPP file, and in the constructor, right where we brought in our sound cue, we're going to instantiate this audio component. And to do that, we're going to say punch audio component equals create default subobject of type UAudioComponent, and we're going to give it a name of punch audio component. So that's pretty good. That instantiates our audio component, and let's just make sure it gets attached to our root component of our player. And this isn't super necessary, but just for sake of consistency, we're going to attach all the components onto our player. And then the last thing we need to do is actually attach the sound cue to our punch audio component. Now, I've been harping on avoiding doing certain operations in the constructor over the last couple of tutorials, and this one's going to be very similar in that regard, where if we say punch component set sound, and then we pass in our punch sound cue, what's going to happen is when this player gets instantiated within the game, this setter that brings in our sound cue will actually trigger the playing of that sound. So you get this weird behavior when the game starts and you hear your sound effect. So I'll show you how this is sort of operating, and make sure you guys avoid this mistake in the past, because it's one of those weird little ones that just kind of sneaks up on you. So what we're going to do is just recompile so you can see how it plays the sound by default, and then we'll end up moving over the set sound definition into begin play. Okay, so with our project recompiled, let's open up Unreal and start our game. So we can close down the blueprint, and then let's just start our game. There you go. Every time you launch the game now, it will play that sound effect. Alright, so that is one of these little weird oddities that you need to be aware of when dealing with sounds. So instead, we're going to take this set sound logic, and we're going to rip it out of the constructor, and we're going to put it in our begin play. So we'll just pop it right after our left and right collision boxes are being set, and we're just going to say if punch audio component is set up, then we want to say punch audio component. Actually, you know what? We'll double check everything. So we're basically saying, hey, if the punch audio component and the sound cue are not null, we're going to say punch audio component, set sound, punch sound cue. And you want to include a little bit of error checking within your game in order to avoid these weird behaviors where things don't work as expected. You get null pointers, and just be aware of error checking and try to put it in early so you're not going back and then sort of compensating for those things later on. So we have our sound, it's attached to our player, it's now instantiated and ready to play. So let's kick it off. And we have already this wonderful little method called onAttackHit, which we added in our last tutorial. And this is where our point of impact with our colliders occurs. So this seems like a really good spot to actually trigger the playing of our sound. And to do that, we can say, hey, if the audio component is ready and our sound cue is also not null, we're going to say punch audio component play. And the play method takes in a start time, so you can kick off the sound from different points within your audio file. And if you have, let's say, an audio file that contains many different sections, you can use this as a way of kicking off those sections. You then just need to be aware of ensuring stops occur at the right points in time. Otherwise, we'll just keep playing into infinity, or however long the file is. So we're just going to say start at 0, and this will play it right from the beginning. So let's recompile and see what this looks like in our game. Okay, we're recompiled, and now let's open Unreal and start our game. Oh, right. So you might have noticed that on game load, we still have the sound effect play. And this is another little bug that I've noticed. If you make modifications to the constructor, some of those changes don't fully get flushed out. So you'll notice whenever it creates these new DLLs to represent your new version of the game, it doesn't clear out the old ones. And the old one is unfortunately stuck in our editor. And to clear that up, you basically have to close down the engine, recompile, which will go ahead and delete those old DLL files, and then open up your Unreal editor, and then those problems go away. So let's just make sure sound works before we correct that. Pretty cool. So now every time we punch, we get a sound effect playing. Now you'll notice it's not 100% accurate, and we're seeing all these on attack hit messages happening on the left hand side because we have no control over our sound effects. We're not checking if it's already playing, we're not checking if our hits are already occurring. So there's a pile of stuff for us to clean up along the way. But let's just clean up this initial constructor issue, and then we'll go back to actually messing around with the sounds. So to do that, I'm just going to simply close down the editor. We'll save all of our stuff, and then I'm going to recompile. And you'll notice during the recompile, there was nothing for it to really correct, but it did remove all of these old hot reload references, which is where our constructor was not being updated. Okay, so with our project recompiled, let's just make sure everything is still working. So there's a guy, there's our punch sound. We don't have anything loading up on start of the game. Yep, nothing loading there. And for the most part, we are done. We have our sound interacting with our object. We have the ability to modify those sound cues through our blueprint. But before we sign off, I want to show you just one little trick you can apply to your sounds if you only have, like in our case, just one effect, but you want to introduce a bit of variance to make the player's ear a little bit more, what's the word I'm looking for? It's going to make it a little bit more variant for them. It's going to make them less, these sounds less repetitive, and it's not going to be triggering those parts of our brain that are associated with familiarity and repetition, and it's going to try to stimulate our brain a little bit more. And as a game designer, you want to consider these things when you're building these mechanics. If you can get away with minimal effort introducing variance into your game, into your sound effects, into your special effects, into your animations, you're all of a sudden providing a lot more depth for the player to interact with. So let's go ahead and just add this one little simple trick by modifying the pitch of our sound effect before we actually play it. And to do that, we'll flip back to Visual Studio, and we'll go to our condition that handles the onPlay event. And you know what, we're actually going to get rid of this check, because if our sound cue is not initialized by this point, we have other problems. But we do want to check that if the sound is playing, or sorry, if the sound is not playing, so we're going to use the exclamation mark in order to negate, or sorry, get the inverse of this Boolean condition before we actually kick it off. And then what we're going to do is we're going to say audio component set pitch multiplier. And you'll notice the pitch multiplier takes in a float. And the default pitch of our WAV file, if we go back to Unreal and we pop open our sound cue, you'll notice the default pitch multiplier is 1. So if we say default pitch value 1F, so if we know that the default is 1, we can now randomize that value up to a certain level. And in this case, we're going to say fmath rand range. And what this little utility method gives you back is a float based on a starting and an ending point. So similar to what we did with our animation montage, where I was doing random integer generation, we can also lean on these helper functions to give us the same amount of flexibility. Now I'm going to leave both versions in just to showcase that you can do it a couple of different ways, but the Unreal Engine does have a pile of these fmath operations and lots of little utils that, you know, save you time and energy, and you have to figure out how to do modulus and all that other jazz. But it's fun for someone who's learning C++, and it shows you different ways of going about it. So going back to our set pitch multiplier, we're going to say give me a random value between 1 and 1.3, and then we're going to kick off the play. So let's recompile and see what this sounds like. Okay, our game has been recompiled, and let me just pop it open here. So there's our guy. And now when we punch, you'll notice there's a slight variance to the way these sound effects sound. Let me just get them in a corner so we can punch it a couple of times. There we go. Alright. Now, if we listen, you'll notice these slight alterations to each hit. It's very subtle, but that slight pitch alteration all of a sudden turned our single wave file into a bunch of different wave files. And as we introduce our soundscape a little bit more, we, let's say, add in a few more punch sound effects, that modulation will all of a sudden generate a pile of variance. And things are going to be just a little bit more nuanced to the ear of the player. But that's kind of it for this lesson. Thank you guys for tuning in, and I hope you come back next time when we start polishing some of these features. So we're going to look at cleaning up our animations a little bit, cleaning up our sound effects a little bit, and generally getting the punching and sound mechanics into a state that's a little bit more presentable. So thank you again, and see you guys next time.